Hi and good day to all of you. Thank you for joining today's free online lesson. Before we get started, I am Nur Akila, the application engineer here at Acad System. So this is my email. I hope that you can see my shared screen and also can hear my voice. So for today's topic is actually the continuation on the previous FOL topic, which is relationship command in Inventor Assembly, which I have already covered for constraint assembly. So for today, I will cover for joint assembly. Without further ado, let's get started. Okay, what is joint? Joint is position component and fully define the degree of freedom. So joints define the part's motion, and also they achieve this with less input and fewer relationship. So a single joint can replace multiple made constraints, for example. So there are 6 types of joint, which is rigid, rotational, slider, cylindrical, planar, ball, and one additional, which is automatic. Okay, first let me accept the participant. Okay, so for better view, I will open my Inventor. So this is the tutorial that we're gonna learn for today that I want to share with you. So for joint, here there are 7 types, which is included with automatic. Automatic is the default setting for when you open the joint. Okay. Right. So what is rigid? Rigid is a joint fits 2 components to one another. So rigid joint will remove all the degree of freedom. For example, of this joint type is applied on welded and bolted joint. So second joint type is rotational. Rotational joint has a single degree of freedom, which is the rotational. This joint can rotate around the X, Y, and Z axis, or around the edge in the model. So for example of this joint is lever arm. Okay. The third type is we have slider. Slider joint has a single transitional degree of freedom. It is used for component that slide along one another. So the component that applied with this joint will slide along the selected axis. For example, like piston. Okay, and then we have cylindrical. Cylindrical joint provides 2 degrees of freedom, which is one is transitional and another one is rotational. For example, like screw. And then we have planar. Planar joint allows 3 degrees of freedom, which is 2 transition in a plane and a single rotational. It is useful for joining 2 components so they can rotate while sliding across the plane. For example, like chess piece, the game chess. And then we have ball. Ball joint has 3 degrees of freedom, which is 3 rotational. Okay, this joint creates a joint that would translate into a ball joint, Acad and other relationship in the world. And then we have automatic. Automatic is it can only read the rigid, rotational, cylindrical, and ball joint only. So it cannot read the slider joint and also the planar joint. And then in this window, we also have gap. We also can name the joint. And we also have suppress if you want to suppress that joint. And then here we have connect, which the origin that we want to connect. And also we can flip the component. And then here is pick part first. If you cannot access the initial the part, you can use pick part. Select the pick first, the part first, and then select the desired edge or part that you want to select. And then we have align. We can align them. We can also invert alignment. Also here is the animate. It will show you the preview of the joint. And then here we have limits. Limits is the availability of the angular and linear options depends on the joint type. So for example, a rotational joint support angular limits only, but linear limits are not available. For example, like I change this to rotational. So the only available limits that we can apply is only angular. Okay, but for rigid, we cannot apply limit for rigid, right? So after we apply the limits, if we apply the limits to a joint, it will mark with the symbol plus/minus. So on the side your joint, we have the small symbol of plus/minus. So that is the symbol for limit. Alright. So once again, thank you everyone for joining today's free online lesson. I am Nur Akila. Okay, to begin with this assembly question, I will click on new file. And then for today, I will use matrix templates. And then I will use assembly part. I will use standard millimeter. Click create. Okay, first I need to place component, the first component, which is here under assembly tab. Under component, you can see the place symbol. We have place from content center. We have place imported CAD file. We have place iLogic component, electrical catalog browser. So for now, I will use place component. Alright. Now the browser for place component is open. I want to open my first component, which is the fixture plate. Okay, you can see the preview. First thing to insert your part in assembly is, for the first part, it is best to place grounded at origin. So you can right click your mouse, and then you can see this marking menu. You can see place grounded at origin, and then it can place at the origin of the assembly origin. So the second step is, as you can see here, my fixture plate is in vertical, so I want it to be in vertical position. So I can change it with using my view cube. So the first thing is I click front to view the front, and then I use this arrow, bottom arrow, and now it is in bottom view, and then only then I can click this corner so that I get the desired position that I want. So I don't want the front, right, and bottom view. I want it to be top, front, and right. So I need to set the view cube. Right click on the view cube, and then you can see set current view as home. Click on fit to view. And then as I want it to be top, okay, and then this bottom change to front, I click on this bottom first, and then right click and then set current view, set the bottom to front. So when I go back to home, you can see that it is now top, front, and right. Okay, next is I want to place the base component. So I will go back to place, open the base component, and then find my base one, open it, and then you can see the preview. Okay, before I place it, I want to rotate it to the X90 so that it is the same position as my fixture plate. So I left click to place the component, and then you can see it is the second preview, which is you can make any copy of the component. So I don't want that. I just want only use one. So right click and then OK, or you can just press the button escape on your keyboard. Okay. Now I want to assemble the base to the fixture plate using joint assembly. I want to use rigid joint to connect the center point of the bottom arc here to this center point of the threaded part. So what I do is under assemble tab, under relationship panel, you can see this joint tool. Click on that. Okay, now I will change the automatic type to rigid. Okay, and then I will rotate my model. I will zoom it so that I can see the center. Then I hover my mouse to this arc slot. Now it highlights the center of the arc. So I click on that. And then for the second selection, which is this second selection, second origin, I want it to place in this center of the thread. So see the preview. Alright, now I need to click. Okay, now that I need to use the alignment, click on this and then click on this. Okay. Alright, so I get my model. So click OK to apply. Okay, I'm done with the base. So next is I will connect the shaft to this hole. So go back to place component and then upload, open my ball shaft. Okay, same as the base, I will rotate this to X90 so that I want to join it on this hole. Right, left click to place and then right click and then click OK to exit the command. Okay. Go to join. Go to join and select midpoint of the shaft. And then the second origin, I need to select the center of this hole. So as you can see that if I go to center, it highlight the outer of the hole. It's not highlight the center of the hole. So one tip that you can use is you can use control button to limit your selection. So for example, I hover my mouse to the hole and then I press Control, and then I move my my mouse, so I select this center. Okay. So you can see the preview is now the type changed to cylindrical. So I want it to be rotational so that it won't slide back and forth. Right? And then click OK. Okay. After that, I will connect the linkage to the end of the shaft here. So I need to open my connector. Open. And then here I want to rotate it to X90. Place it on the assembly area and then click OK. I will connect this connector pin here to this hole. So on the ribbon, click on Join Tool. And then select the midpoint of the pin here for the first origin. And then select the center of this hole. If you notice again that I cannot access the center here, it highlight another part. So remember the tips earlier I told you to use control button. So you go to this hole until it highlight the entire hole, and then press control and then move your cursor and then select your desired origin. So I want this midpoint. Click on that. So you can see that from the automatic type, it's changed to cylinder. So if you don't want the type, you can change it according to your need. So for this connector, I want it to use rotational so that it just rotates. Okay. And then I click OK to apply that. Alright. And then moving on, I will place the lever on here. So this is the lever. So I need to place my lever first in my assembly area. So go back to place component and then find my lever. This is the challenging because I need to rotate it. So this is not the desired position that I want. So I need to rotate it twice for Z 90 and then for rotate X 90 once. So this is the correct orientation position that I want. So I click on that to place and then right click OK. Now I want to connect this hole with this pin connector on here. So what I do, I can use, as you notice that in here there is no origin or something that you can choose. It is empty here. So what I can do is I can use between two faces. Okay. When to use these options? You can use this option is when you want to easily access the origin between the two faces. You can use the option by select two faces until it creates a midpoint, midplane, and then select the point in between them. So it is very useful in joint assembly to have this option, as you don't have to create work plane. Just use the between two faces option. Okay, so I select this between two faces. I zoom it, rotate so that I can see the face. So I click this first face and then this second face. So now you see that it highlight both face, and then when you see my I have my mouse, it highlight the midpoint on here. So I want to choose this midpoint, right click. Okay. And then for the second selection, which is this pinhole. So click on that. So that now you see that the type is rigid. I don't want this lever to stay on the pin. I want it to rotate. So I change the type to rotational. So you see the preview. Okay. And then click OK. And then next, I want to connect this to this hole. I want to use traditional constraint. I will just use make constraint here and then select this edges. And then click OK. See? Wait. Okay. I don't know why. Okay, let me delete this and then repeat the step. Okay. Repeat the step, use make constraint, and then select this edges, and then select this. Go back to home, and then apply OK. Alright. Let's see why my lever cannot move. Is that because I use link? No. Let me check. Oh, alright. So for this, I need to change the type to cylindrical. So that, okay, I cannot move this lever because my ball shaft is on rotational, so it cannot slide back and forth. So I change the cylindrical. As you can see that when I play the animate, you can see that my shaft can move back and forth. So I click OK. And then when I play, now you can see that I can move my lever. Alright. Okay. And then next is I want to place a socket part here. So for socket part, I will move this so that I view the left view. And then go to place component and then find my socket model part here. And then this I want to rotate X 90. So I want to connect the socket on this ball shaft. So left click to place and then okay. Let me change the view so that you can see the inner. Okay. Now I want to join this together. Go back to assembly and then join. I select the inner spherical of this socket and then the midpoint of this ball. See the preview. So it shows that the ball joint is now applied on that. Right. So click OK. Alright. In Inventor, for join, it has lock and protect. lock and protect. Okay, what lock and protect can do is first lock. It will eliminate all degree of freedom but allow the component to change location when related component move. I will show you what it means. So lock is different with grounded. So as ground, component will also eliminate all degree of freedom, but it fits the component to the position. So when you move, when you use ground, it will not give allows you to move your component. But if you use lock, it still can move the link. So for protect, use protect on join to one if added relationship violate the required motion. Right. So I want to apply lock on this so that it cannot move like this. So what I do is it align, it face downward. So go to align, select these edges and then select this highlighted so that this my model for the socket is on this orientation. Okay. So for the alignment, you can choose any edges as you want, as long as the model is on the correct alignment, correct position, orientation. So this is my model. I want to lock this. So before that, I want to rotate this socket to 90 degree so that it faces on the right. So what I do is I click on this model socket, right click, and then select free rotate. Okay, and then I click in here and then move my cursor to this. So something like this 90 degree, right click and then that. Right? And then you can see that it is not located with the ball. So don't worry. You can move this lever. Okay, I move this lever and then this will update. Okay, now that the socket is go back to the ball and then it will update it. Alright, and then now I want to lock this. I go back under my model 3, you can see this relationship folder, expand that, and then you find the ball join that I have created, right click on that and then just click lock. So that now my socket is not move, it cannot freely move, but it still apply ball join on that area. Okay. Okay, for the last step is I want to complete this tutorial by adding this hand grip. So go to this component and then find my grip and then rotate to X90. Okay, to join this, I will use between two faces. Okay, turn on my join tool, right click on this area and then select between two faces. And then I select this first face, this second face, and then I want to choose this midpoint of the arc. Okay, that is for the first origin. And then for the second origin here, right click and then choose between two faces. And then click on this face and then this face and choose this. Okay, if you see the preview, okay, it is not in the position that I want. So it is the time when I use align so that I align this with this. See, it is now in the correct position that I desired. Okay. So this is the okay. I silap. This is I want to apply rigid so that it cannot move. So it is fixed to the area. So I change the type to rigid. See? Okay. So that is all for the tutorial. Jadi I nampak ada soalan. Okay. Hi, what is the difference between constraint and join? Alright. Constraint is it actually save your time. You can also use constraint to constrain them, and also you can use join to use to assemble your model. So in constraint, it is more not complicated, but it is require lots of work. Okay, so here you need to know which type of constraint that you need to use. Okay, and then here are the solution. Okay, when you use join, it creates motion on that. It is easier for you to assemble that what you imagine. Like you want this ball shaft to move back and forth, and then you can use join cylindrical. Okay, I hope that answer you. Okay, if you want to see the constraint relationship, you can go to our website. You can go to our website. You can type in acadsystems.com. And then bawah ni you can find us on Facebook and also YouTube. So I already covered the constraint assembly. You can find the video is this relationship command in Inventor Assembly. And this is the first part. I cover for assembler and for motion constraint. And then this is the second part for the transitioner and the constraint set. So you can watch the video to understand how the Inventor constraint assembly works. Alright. So as we at it, you can also subscribe our YouTube channel so that you can miss out our latest free online lesson. So here we have covered many topics that we have already covered. So we have Plan 3D. If you want to learn about piping modeling, you can view this video tutorial. And we have also by playlist. If you want to master in AutoCAD, you can watch this tutorial. And also by collection, which is here, you can know BIM, you can learn Inventor Nasran and all. So we also have AEC folder, which is you can learn Revit, Civil 3D and all. So if you have free time, you can watch our video and like the video. Okay. And then while we at this our website, you can read this a little bit about our company. We are the Autodesk partner. We sell Autodesk software. So here under product, you can see a lot of Autodesk product that we sell. We sell Civil 3D. And also here we have latest Autodesk promotion. If we have flash sale, it will appear here. And then here is the updated of our next free online lesson. So for tomorrow, we have Fusion 360 mesh modeling. If you have time and you want to learn about this Fusion 360, you can go to this flyer, click on this flyer, and then just fill in your RSVP here to secure your seat. Okay. Okay, and then if you have any question or you want to ask about the product or quotation, you can have a live chat with us here. The small button, you can have live chat, and then our available team will respond to you immediately. And then also, if you want to submit a form, also can. Or you want to call us, you can contact through this number. Right. Okay. Let me do the. Okay. So I hope that you understand my today's pre-online lesson. Go ahead and try this out on your own and see yourself how it can help you in the future. So this is the end of our lesson for today. I hope to meet you on another online lesson. Thank you. Thank you, Alif. Thank you, Faris Hisham. Thank you, Hanan. Thank you, Muhammad Zam. Thank you, NY Marketo. Thank you, Shakti, for joining me today. So have a good day. Bye-bye and Assalamualaikum.